Good morning students, myself Dr. T. Susan Ram Parmal, Associate Professor Easy Department. Today we are going to see about the window stacking method in the FAR filter. So first we go for see about the types of windows method. Here we have the two different window method. First one is rectangular window, which will be represented by WR of n. The value for WR of n is equal to 1. Second we go for Hamming window. So the transfer function of Hamming window WHM of n is equal to 0.54 minus 0.46 cos 2 pi n divided by n minus 1 for 0 less than or equal to n less than or equal to n minus 1. Then Hamming window, right, WHN of n, the value is 0.5 minus 0.5 cos 2 pi n divided by n minus 1 for 0 less than or equal to n less than or equal to n minus 1. Then we go for the see the characteristics of the window function. The central lobe of the frequency response of the window should contain most of the energy and should be narrow. The highest size lobe level of the frequency response should be small. The side lobes of the frequency response should decrease in energy rapidly from omega tends to pi. Now we go for the problem. Using a rectangular window technique, design a low pass filter with passband gain of unity. The cutoff frequency is 1000 Hz and working sampling frequency of 5 kHz. The length of the impulse response should be 7. So the length of the filter is having the value of 7 and the given is cutoff frequency fc is equal to 1000 Hz and sampling frequency fs is equal to 5 kHz. From that we are going to calculate the original cutoff frequency. Wc is equal to 2 pi fc by fs. So we get 2 pi by 5. So desired impulse response is hd of n is equal to 1 by 2 pi integral. The value is minus 2 pi 5 to 2 pi by 5. The value, frequency response value is amplitude value is 1 into e power j omega n into d omega. So from that we are going to calculate hd of n, that's equal to 1 by 2 pi e power j omega n divided by j n with respect to minus 2 pi by 5 to 2 pi by 5. So we apply the limits, so we get 1 by pi n into 2j into e power j 2 pi n by 5 minus e power minus j 2 pi n pi by 5. So from that we get hd of n is equal to sin 2 pi n by 5 to pi n. Then we are going to calculate the h of n value. So h of n value is, first we get h of 0 is equal to limit n tends to 0 sin 2 pi n by 5 to pi n. So already we say that for h of 0 we apply the L hospital rule, that is limit n tends to 0, theta tends to 0 sin n theta divided by theta, the value is n. According that we get sin 2 pi by 5 into pi n divided by pi n, so we get 2 by 5 and hd of 1 2 is equal for hd of minus 1, the value is 0.3027. h of 2 is equal to h of hd of minus 2, the value is 0.0935. hd of 3 is equal to hd of minus 3, the value is minus 0.06236. and the rectangular window function wr of 1 is equal to 1 for minus n minus 1 by 2 to less than or equal to n minus 1 by 2. So the every value of wr of n, the value is 1. So simply we have h of 0 is equal to hd of n into wr of n. So we get h of 0 is equal to 0.4, h of 1 is equal to h of minus 1, which is equal to 0.3027, h of 2, h of minus 2, the value is 0.0935 and h of 3 is equal to h of minus 3, the value is minus 0.06236. For getting h of n value, we multiply hd of n with respect to the particular given window function wr of n, and then we go for calculate the transfer function, normal transfer function h of z. So the formula is h of z is equal to h of n into summation n is equal to 0 to n of minus 1 by 2 z power minus n plus z power plus n. So h of 0 value is 0.4 plus h of 1 value is 0.3027 into z power n 1 plus 0.3027 into z power minus 1 plus 0.0935 z power 2 plus 0.0935 z power minus 2 minus 0.06236 z power 3 minus 0.06236 to the power minus 3. Then we are going to calculate the realizable transfer function h dash of z, that's equal to z power minus n minus 1 by 2 into h of z. The value is z power minus 3 into h of z. So we get 0.4 z power minus 3 plus 0.3027 z power minus 2 plus 0.3027 z power minus 4 plus 0.0935 z power minus 1 plus 0.0935 z power minus 5 minus 0.06236 z power 0 minus 0.06236 z power minus